So how is it that we're solving quadratic equations? We're solving them by factoring, applying the zero product property. So let's take a look at exercise 12 here. 4x squared minus 17x minus 15 equals 0. Maybe this one looks a little scarier to factor, but I think we can handle it. Let's see. So let's open up our parentheses. Let's try guessing and checking. Right? So these first two have to multiply up to 4x squared. I can try 4, 1 or 2 and 2. Let's try 2 and 2. 2x and 2x. I don't know if it'll work. Let's just see. The last ones have to multiply up to 15. How about 3 and 5? So I'll put a 3 here and a 5 here. Inside I would get 6. Outside I'd get 10. That gives me 16. No matter what, that's not going to work. If I switch them, they're exactly the same sum. So obviously that didn't work, so I need to go back. I can change the 3 and 5 to 1 and 15, but that's unlikely. So I'm actually going to try changing the 2's to a 4 and a 1. So a 4x and an x. 1x. Okay, so the outside would be 20, the inside would be 3. I can get 17 from that as long as it's negative 5 and positive 3. Well, there we go. Just factored it. So the first one, can you go straight to the answer without actually having to write down the little equation? I would subtract over the 3. I would divide it by 4. I would get x equals negative 3/4. Okay, and over here on the right hand side, it's just the opposite of that. X is equal to 5. All right, look at number 3. Why don't you try number 2, 3? Why don't you try number 2 by yourself? And you might be going, well, what am I supposed to do? I got stuff on both sides. Well, get everything on one side of the equation, and then you can apply that zero product property thingy again. All right, so whenever you get everything over to the left-hand side, you get 3x squared plus 36x plus 108. Okay, so we know that whenever we go to factor, the first step is always to pull out the GCF. And each one of those is a multiple of 3. So you could factor out a 3. The thing is since this is an equation, you could just as easily divide both sides by 3, the GCF, and get rid of it. So you're left with factoring x squared plus 12x plus 3 equals 0. So you can divide both sides by the GCF if it's just a constant term, like 3 or 2 or something like that. If your GCF is x, though, don't divide both sides by x to get rid of it, because that x could be one of the zeros, right? Okay, so that's a perfect square trinomial because half of 12 is 6, 6 squared is 36, which means it factors as x plus 6 squared. You only have one answer, and it's x equals negative 6. Okay. So you ready for some geometry? So find the value or values of x. What I have in the picture here, two intersecting lines, those are vertical angles. What's the relationship between vertical angles? They're equal to each other. So these two angles, whatever they are, have to have the same measurement. So I'm going to write 2x squared is equal to 15x minus 7. Right? Those two angles are equal to each other. And let's get everything on the left-hand side. 2x squared minus 15x plus 7. And factor it. So, open up our parentheses, a 2x and an x. And the only thing that's possible is going to be a 1 and a 7, since that's prime. Put the 7 opposite the 2 so that we can get 14, and the middle one is 1. This would add up to 15 if they're both negative. They have to be to make the signs work. So here I have x is equal to 1/2, and on the other one, x is equal to 7. So technically both of these answers would work, but one of them kind of doesn't make a whole bunch of sense. For example, if I stick in this 1/2 here, 2 times a half squared is 2 times 1/4, which is 1/2. Do you think that angle is a half a degree? I don't think so. So I'm going to say this one is unlikely. And the x equals 7 is the one that makes probably a little bit more sense, because that would be 2 times 7 squared, which is 2 times 49, which would be 98 degrees. 98 degrees, that's hot. Okay, How about this one? How about this one? More geometry. Find the value of x if the area of the triangle is 42 square units. So we have a base length down there, 2x plus 8, and we have a height of x plus 3. Crazy. So we know that the area formula for a triangle is a half of the base times the height. So my area is 42. That's equal to 1/2 of the base, which is 2x plus 8, times the height, which is x plus 3. Okay, so now that 1/2 that's right here in front, you could do a couple of things with that. You can multiply both sides by 2 to get it over there on the left-hand side. Or I can multiply it through this first set of parentheses, this first factor, not both of them, because if I did it by both of them, it'd be like multiplying by 1/2 times 1/2, which is 1/4. I'd want to do it on the first one because they're both even, and it would make this a little bit easier to work with. So I got 42 is equal to, take half of both things in that first parentheses, I get x plus 4 times x plus 3. Okay, now FOIL the right hand side. We're going to have to FOIL it out, subtract 42 over, and then factor. Okay, so 42 is equal to x squared, middle term is going to be 4x plus 3x is 7x. And then plus 4 times 3 is 12. So subtract over the 42. 0 is equal to x squared plus 7x minus 30. And, right? I think so. So what do we got? We've got 2 and 15. We've got that have to multiply up to 30, and that's not going to give us what we want. 5 and 6. That's not going to work. Oh, wait. What about 3 and 10? 3 and 10. That'd give us 7 if the 10 was positive. So 0 is equal to x plus 10 and x minus 3, which means that x could be equal to negative 10 or 3, right? All right, so with a geometry problem, just like on that last one, you want to make sure if your answers make sense with a picture. So if you stick in negative 10, I would have a height of negative 10 plus 3, which is negative 7. What? No, that's not going to work. So negative 10 is definitely not an answer. Not just unlikely, it's definitely not an answer. So you're only left with x equals 3. Okay, one more. This one's pretty tough. See if we can handle it. Use substitution to solve this system of equations. And I have a quadratic and I have a line. So if I just think about this graphically for a second. If I have a parabola, maybe it looks something like this, and then I have a line, whenever I go to solve this thing, I'm looking for where they intersect. And it's possible that they intersect at 2 places. So I may be looking for 2 coordinates. Okay, that's not the only possibility, but that is one of the possibilities. Maybe I'm looking for 2 places where they would cross each other. So, and it says use substitution to solve this. Substitution, I take something out and stick something that's equal to in its place. Look, they're both solved for y, so I can take this 6x plus 5, which is equal to y, and stick it into y in that top equation. So I would have 6x plus 5 is equal to 2x squared plus 3x minus 4. Now let's get everything over here on the right-hand side so we can apply the zero product property. 2x squared. I would subtract the 6 over from the 3. I'd have negative 3x. Subtract the 5 over with the negative 4. I'd have negative 9. Okay, so let's try to factor this thing. So 0 is equal to, let's open up our parentheses, guessing and checking. Obviously 2x and x, because that's prime. And how about a 3 and a 3 for our 9? Let's hope I put those in the right spots. So the outside would be 6, the inside would be 3. That would give us 3, as long as the outside 6 was negative and that one's positive. Okay, so for the first factor, I get x is equal to, subtract the 3 over, divide by 2, negative 3/2. Okay, and on the second one, x is equal to 3. Now I'm not done yet because those are just the x-intercepts. Those are the two x-coordinates where our line touches the parabola. We need to find the y-coordinates by substituting those back in. Well, which one of these is going to be easier to substitute it back into? The line. Y equals 6x plus 5. So let's make it easy on ourselves and put them in there. Okay, so y equals, let's do the first one here, 6 times negative 3 halves plus 5. So do the dividing part first. 6 divided by 2 is 3, times negative 3 is negative 9, plus 5 is negative 4. So our first coordinate is negative 3 halves, negative 4. Okay, now let's do the next one. So I plug in a 3, run out of room here. Y equals 6 times 3 plus 5, that's 18 plus 5, which is 23. And I would have a point of intersection at 3, 23. Alright, that was a pretty fun problem to do, right? I know, it sure was. Okay, so that concludes our lesson on solving quadratic equations, specifically by factoring what we see in the picture there. That's that Margaret Hunt Hill Bridge in Dallas. It has the shape of a parabola, and you can see where it kind of looks like crossing the x-axis there at the road. And so here's your assignment, and I'll see you in class.